Good evening. Tonight we are going to discuss GCSE Foundation Tier. For the session today you will need writing equipment, i.e. pen, pencil, a book to write in, a calculator, a smartphone, tablet, PC or laptop that is connected to the internet. If the writing is too small, then please use the Zoom, which can be found at the top of the platform. If you have any questions during the session, then make a note of them and use our £2.50 specific question service after the session has finished. Text us for details. Our target today is to improve GCSE Foundation Mathematics, improving exam technique and exam timing. So, how this session is going to work. First of all, you're going to write down the questions and then you're going to have a go at these questions in your book. Then I will go through them with perfect answers. Okay, so question 1. How many centimetres are in 3.7 metres? And that is for 1 mark. Now in exams, 1 mark is about 1 minute approximately, just under. So we're going to try and get your exam timing up to scratch before you sit your final exam. Okay, so question 1, how many centimetres are in 3.7 metres? Question 2, how many vertices does a triangular prism have? And I'm going to give you 90 seconds to have a go at these 2 questions, and then I will go over them. Okay, so about 15 seconds left. Okay, so question 1, and that was, how many centimetres are in 3.7 metres? Now, as we all know, there are 100 centimetres in 1 metre. So if we've got 3 whole metres, then that would equal 300 centimetres, and 0.7 metres is 70 centimetres. So it will be 300 centimetres, add 70 centimetres, which is 370 centimetres. Question 2, and this was, how many vertices are in a triangular prism? Now a triangular prism, what I think of one of those is the Toblerone chocolate bars. Okay, so if you Google a picture of one of those and then you count the corners of the shape, and you'll notice that there are 3 on one side of the triangle, and then if we go all the way to the other side there are also another 3. So there are 6 vertices. Vertices are the corners of shapes. So well done if you got those two correct. And now we've got to move on to question 3. So question 3. Which decimal is the same as 3/8? Question 4. Simplify 4a minus bracket 3a plus 5. And question 5, if you can complete the table that you see in front of you at the moment, please. Okay, so I've assigned 4 minutes for you to have a go at these 3 questions. So good luck, and I'll see you again in 4 minutes. Just one point to make. In general, as you're going through a foundation tier paper or a higher tier paper, the questions in general get more difficult as they go along. So these are the more straightforward questions. Okay, they do get a lot harder as we get towards the middle and the end of the paper. So you've just got just under 2 minutes left to complete those 3 questions. Okay, so just 1 minute left now. Okay, so question 3. And question 3 was, which decimal is the same as 3/8? Now, most of us know that 1/8 is a half of 1/4. So we know that a quarter is 0.25 written as a decimal. So if 1/8 is a half of a quarter, then 1/8 would be 0.125. So if 1/8 is 0.125, and what we're after is 3/8, we times 0.125 by 3. Or we can add 0.125 plus 0.125 plus 0.125 to get 3/8. And 3/8 is 0.375. So give yourself a big well done if you manage to get that one right, because that one is quite a tricky one. Next one, question 4. Now question 4, there is a trick to question 4. And that is, first of all, the question is 4a minus, open bracket, 3a plus 5, close bracket. Now, we have to include the 1 between the negative and the first bracket. And that is our number that we've got to times everything in the bracket by. So basically what we're doing here is we're timesing the -1 by the 3a, and that gives us negative 3a. And then we've also got to times the -1 by the 5, which would give us the negative 5. And then we collect like terms. So what we've got so far is 4a minus 3a minus 5. So we collect the two terms with an a included in them. So it's 4a, take away 3a, which is a, and the 5 doesn't have an a term in, so that just stays as -5. So the answer is a minus 5. Question 5. So question 5 was, if we had 30 minutes, what would that be in hours? And 30 minutes is half an hour, and it's 0.5. Next one, 40 minutes into hours. Now 40 minutes is 2/3 of an hour, and 2/3 written as a decimal is 0.666666, but we round the last 6 off to a 7. So anything like 0.667 or 0.6667 is absolutely fine. So 40 minutes is 0.667 hours. Next one. So what we're after is 2.25 hours in minutes, and what we've got is 2 hours, or 1 hour is 60 minutes. 2 hours is 120 minutes. And the last one, 0.25, and that is a quarter of an hour. And a quarter of an hour is 15 minutes. So if we've got 1 hour, which is 60, 2 hours, which is 120, and then another 15 minutes, if you add those together, you get 135 minutes. Next one was 1.75 hours. How many minutes is that? So 1 hour, again, is 60 minutes, and 3/4 of an hour is 45 minutes. If you look at the clock, you've got 1/4, which is quarter past, which is when the minute hand is pointing to 3, half past, which is when the minute hand is pointing to 6, and then 1/4, which is 3/4 past. So therefore 1 hour is 60 minutes, and the 0.75 is 45 minutes. So if you combine those two, you get 105 minutes. Give yourself a big well done if you managed to get all of those correct. And we're going to move on to your term. Question 6. So again, we've got to write out the questions and then answer them. So, give any equivalent fraction to 9/16. And here are some numbers separated by commas. Write the numbers in pairs so that the sum of each pair is the same. So, and those are your numbers: 9.6, 12.6, 15.4, 12.4, 7.6 and 17.9. Question 8. What is the name of a triangle with two sides of equal length? Okay, so I've allocated 4.5 minutes for these questions. So good luck and have a go. Okay, so you've got about 2 minutes left to have a go at those 3 questions. So question 6 was give any equivalent fraction to 9/16. Okay, so an equivalent fraction is a fraction where you have multiplied the numerator, and that's the number on the top, and the denominator by the same number. So for an instance here, we started off with 9/16, so 9 is the numerator and 16 is the denominator. So if we times the top, which is the numerator, by 2, we would get 18, and if we times the denominator by 2, we would get 32. So 18/32 is one equivalent fraction. Now another equivalent fraction would be if you times the top number by 4 and you also times the bottom number by 4. So therefore 36/64 would also be an equivalent fraction. Now you can times the top, the numerator and the denominator by the same number, and so you could have, for instance, 90/160 if you times top and bottom by 10. Okay, so question 7. And question 7 was, we had some numbers and we had to write the numbers in pairs so that the sum of each pair is the same. Okay, so the general theory behind this is you find the lowest number, and the lowest number would go with the highest number, and then the next lowest number would go with the next highest number, so that when you combine those two, they should equal the same amount. Okay, so the answer that I got was, I put 17.4, which is the highest number, with 7.6, which is the lowest number, and when you add those two together, you get 25. 15.4 was the next highest number, and 9.6 was the next lowest number. So if you add those two together, you get 25. And then I was left with 2 in the middle, which were 12.6 and 12.4. And when you add those two together, they also equal 25. So the pairs are 17.4 and 7.6, 9.6 and 15.4, 12.6 and 12.4. Well done if you managed to get that one correct. So question 8, and the question was, what is the name of a triangle with two sides of equal length? And the answer, of course, to that one is an isosceles triangle. Now, really well done if you managed to spell isosceles right. It's a very strange looking word, but you don't get marked down for bad spelling in a maths exam. Okay, so well done if you managed to get all 3 of those correct. So we're now on to question 10. Sorry, question 9. Okay, so question 9, and this is your turn. So again, write down the question and have a go at it. So question 9 is work out 51% of 400. Question, and you've got 2 marks for that one. So again, there will be 1 mark for working out in an exam. So just get in the habit of whatever you think, write down on the page and try and get it in a logical manner. Question 10. Write 180 grams as a fraction of 3 kilograms. And again, that's 2 marks, so if you think it, write it. Question 11. Here are some properties of numbers: even, odd, prime, square, and 2-digit. Now 2-digit is, for an example of that, is 11 or 13. So it's just a number with 2 numbers in. Okay, so part A, which 2 properties does the number 4 have? So is it even, odd, prime, square, 2-digit? And part B, can one number have all the properties? And part C, write down a number with 3 of the properties. Okay, So I've given you 6 minutes for this. So good luck, and have a good go. Okay, so these questions that I've taken are really good examples of exam questions. They're not too hard, and they are actually from past exams and future exams as well. Okay, so you've got about just over a minute left for those questions. Now do remember that these are non-calculator. Okay, so let's have a go at the first question, which is question 9. Work out 51% of 400. So, now usually we're used to working out 10%, 30%, etc. So this one is quite a tricky one. But first of all, what we've got to do is we've got to work out what 50% is. Now 50% is a half. So a half of 400, and that is 200. And this bit here I think is the tricky bit coming up. But my sort of philosophy of working out non-calculator percentages is you've always got to work out what 10% is, and then you can either divide or times from there. So for instance, if you're after 30%, you would work out 10%, what 10% is, and then times that by 3. Okay, so here we're after 1%. So if we work out what 10% is, and then we divide both sides by 10 to get what 1% is. So 10% of 40 of 400 is 40. So 10% you just move the decimal place one place to the left. So 10% is 40, so you've got to divide 40 by 10, which is 4. So 1% is 4. So 51% is, you've got 50%, which is 200, and you've got 1%, which you've worked out to be 4, so you just combine the two to get 204. Next one, and this is question 10. And question 10, which is quite a tricky one, again 2 marks, so you've got to show working out. Write 180 grams as a fraction of 3 kilograms. Now wherever you see the word write something as a fraction and it's 2 marks, you know that there's going to be some simplification to get full marks. So first of all, and when you've got 2 things that are in different units, i.e. grams and kilograms, meters and centimeters, you've always got to get them into the same unit. Now I prefer to get them both in the smaller unit, which in this case is grams. Okay, so we know that there's 1,000 grams in 1 kilogram. So therefore, we've got to get the 3 kilograms into grams. So 3 kilograms is 3,000 grams, and then all we do is put it as a fraction. So as we can see, 180 over 3,000. If you divide 180 and the denominator by 2, so 180 divided by 2 is 90, and 3,000 divided by 2 is 1,500. Now again, 2 goes into those two, those two numbers. So 90 divided by 2 is 45, and 1,500 divided by 2 is 750. Now, we get to 45 over 750. So what's the biggest number that we can quickly think that goes into 75 and into 45 and 750? And the answer to that is 5. So 45 divided by 5 is 9. 750 divided by 5 is 150. Now, a lot of you might have finished there, but 3 goes into 9 and 150. So what we can do is divide top and bottom, 9 and the 150, by 3. And 9 divided by 3 is 3, and 150 divided by 3 is 50. So the answer is 3 over 150. So you always put fractions in its simplest form. Okay, so question 11, and question 11 was, here are some properties of numbers: even, odd, prime, square, 2-digit. Which 2 properties does the number 4 have? Okay, so the number 4 is an even because it's 2, 4, 6, 8, yeah, even number. And it's also a square number because it's 2 times 2 is 4. Now, square numbers are when you times the number by itself. So 1 times 1 is 1, so 1 is a square number. 2 times 2 is 4, so 4 is a square number. 3 times 3 is 9, so 9 is a square number, and so on. So 5 times 5, 25, 25 is a square number. Question 11b. And question 11b is, can one number have all the properties that we listed? Now, no, because a number can't be even and odd. Okay? 11c. And 11c, I think this one was quite a tricky one. Now, 11c was write down a number with 3 of the properties. Now, there's actually a lot of numbers that this can be. So I've just picked out the square numbers that are greater than 10 but less than 100. Okay, so basically, greater than 9 but less than 100. So 4 times 4 is 16, and 16 is a square number, it's 2 digits, and it's even. So that's one example. 25 is a square number because it's 5 times 5 is 25. It's 2 digits, and it's also an odd number. And you've also got the prime numbers as well that I haven't listed. But so for instance, 23. So 23 is odd, it's 2 digits, and it's a prime number. Okay, so I mean, a prime number is a number that is divisible by itself and 1. So your prime numbers are 2, 3, etc. Okay, so we're now on to question 12. And this is the start of the 4-mark questions, really. Okay, so Sarah has 6 coins in her pocket. If she picks out 5 coins, the most she can pick out is £4.60, and the least she can pick out is £2.70, and that's with 5 coins, 5 out of the 6 coins. What is the total of the 6 coins? Okay, so that's 4 marks, so there's a lot of marks there. There's at least 3 marks for working out. Question 13. Here are 3 expressions, b over a minus b, and ab. When a is 2 and b equals -6, which expression has the smallest and highest values? Okay, so I've given you 7 minutes to complete these 2 questions. Okay, so if you just write out the questions and then have a go at completing them. Okay, good luck. Okay, so you've got about 2 minutes left. One minute left. Okay, so question 12, which you've just had a go at, is Sarah has 6 coins in her pocket. If she picks out 5 coins, the most she can pick out is £4.60 and the least is £2.70. What is the total of the 6 coins? Now everyone loves a wordy maths question. So, question 12. Now the way I tackled this question was I concentrated on the £2.70 first. Now, how could I make up £2.70 from 5 coins? And you can't make it up using like a £2 coin. So then I tried, so 2 £1 coins, a 50 pence and 2 10 pences, which is £2.70. Then, from those 5 coins, I knew that I would have to use 4 of those coins plus the one that was left from the 6th coin in order to make the £4.60. So what I did, I took away one of the 10 pence coins from the £2.70 5 coin, and then I added a £2 coin. So the 5 coins that added together to make the £4.60 would be 1 £2 coin, 1 £1 coin, 1 £1 coin, 1 50 pence and 1 10 pence, which when you add those together add up to £4.60. So I've got the 6 coins now, and the 6 coins are the £2, a £1, another £1, a 50 pence and 2 10 pences. So the total of the 6 coins, you just add those together and you get £4.70. Okay, so well done if you managed to get that correct. Remember, show all stages of your working out, like the adding up and how you've come across the £2.70 and the £4.60. Okay, well done. So, question 13 now. And question 13 was an algebraic substitution question. So here are 3 expressions: b over a minus b, and ab. Now ab is just a nice mathematical way of writing a times b. So in maths, where you don't see a symbol between 2 letters, it just means times. Like 2x is 2 times x. When a is 2 and b is negative 6, which expression gives the smallest and the highest value? Okay, so basically we substitute our values for A and B into the expressions. So the first one is B over A, and B is minus 6 and A is 2. So minus 6 divided by 2 is minus 3. Next one, and it was A take away B. A is 2 and B is negative 6. So A take away B becomes 2 take away negative 6. And where you get two negatives directly next to each other, that changes and it becomes a plus. Basically, a takeaway means the difference between the two. So the difference between 2 and negative 6 on a number line is 8. Next one was A times B, or AB. A is 2 and B is negative 6. 2 times negative 6 is negative 12. So the smallest value is AB, which is negative 12, and the highest value is A take away B. Very well done if you managed to get full marks there. Okay, so next question, and this is a ratio question. So the ratio of teachers to children needed for 2 activities, and this is what we do when we take pupils out on school trips. We've got to have so many teachers per pupil for safety reasons. Okay, so the ratio of teachers to children needed for 2 activities is shown. So basically for climbing, you need 1 teacher for every 4 children, and that's because it's quite a dangerous activity. And walking, which is less dangerous, you need less teachers per child. So 14A. There are 7 teachers to take children climbing. What is the greatest number of children that can go climbing? And 14 part B. 49 of children wanted to go walking. What is the smallest number of teachers needed? Okay, so you've got 3 minutes to complete those, and then we'll go through them. Okay, so good luck and have a go at them. Okay, so you've got about 30 seconds left for those 2 questions. Okay, so 14A. There are 7 teachers to take children climbing. What is the greatest number of children that can go climbing? Okay, so basically the ratio of teachers to children required for climbing is 1 teacher for every 4 children. So therefore, this is how we set out equivalent ratios. So the T stands for teacher and the C stands for children. So for every 1 child, for every 1 teacher that goes, you can have 4 children that go. So what we want to know is how many children can go if 7 teachers go. So what we've got to do is to times the 1 by 7 to get up to the 7 teachers. So what we do to one side, we've got to do to the other side. So it will be 4 times 7, which is 28 children. So 28 children can go. 14B. So 14B was 49 children want to go walking. What is the smallest number of teachers that are needed? Okay, so we know that for every 9 children that want to go for a walk, we need 1 teacher. So, again, we set it up teachers and children. So for every 1 teacher, we've got 9 children. So, we times it by 5 to get up to the 45. 45 children, and for 45 children to go, we require 5 teachers. Now 45 isn't enough for the 49 children to go. So either we leave the 4 children behind, which unfortunately we can't do, so we've got to go up to the next one. So instead of 5 teachers, we would require 6 teachers. And that means that 5 more children can actually go on the trip, because all we wanted was 49 children. But with 6 teachers, we can take 54 children. Okay, so well done with ratio, if you managed to get that correct. If not, please do get in touch and we'd be more than happy to explain some more ratio to you. Okay, so we've just got time for one more question. So if we have a go, question 15 will take too long. So if we have a go at question 16. So textbooks are stored on 2 shelves. Each shelf is 0.72 metres long and each textbook is 30 millimetres wide. Can 50 textbooks be stored on these shelves? Okay, so have a go at this question and good luck. I'll give you 3 minutes to have a go at this question. So textbooks are stored on 2 shelves. Each shelf is 0.72 metres long. Each textbook is 30 millimetres wide. So just imagine how the textbook would look when you put it on a shelf, like a DVD. Okay, so just a quick reminder of the question. Textbooks are stored on 2 shelves. Each shelf is 0.72 metres long and each textbook is 30 millimetres wide. So we've got metres and millimetres. So what we're going to have to do is to get both of those into the same unit. Can 50 textbooks be stored on these shelves? Okay, so what I did first, I changed the 30 millimetres into centimetres, and of course there's 10 millimetres in 1 centimetre. So 30 millimetres is 3 centimetres. Next, I changed the metres into centimetres, and 0.72 metres, if you times that by 100, because there's 100 centimetres in a metre, you get 72 centimetres. So therefore, each shelf is 72 centimetres long, and there are 2 shelves. Okay, so if there's 2 shelves of 72 centimetres long, you've got to times 72 by 2, which is 144 centimetres, and that's the total length of the 2 shelves. So now what we've got to do is to work out how long the 50 books will be. So 50 books times 3 centimetres, so that's because one book is 3 centimetres thick. So 50 times 3, 5 times 3 is 15, add on the 0, so therefore the 50 books is 150 centimetres. So they would be overhanging by 6 centimetres, so the 50 books will not fit. Well done if you managed to get that correct. And that is us done for this hour. So we have completed just over the first half of a GCSE foundation tier exam. Point to remember, always show all stages of your working out. More marks in exams. If you've got any questions regarding any of the answers, please do not hesitate to contact me. We are more than happy to explain any specific maths GCSE questions for only £2.50. We will see you next week. Thank you for listening.